In this last section on trigonometry, we'll be looking at the angle of depression and the angle of elevation. In the diagram, you can see that the angle of depression is how much you look down, or the angle that you look down at, from the top of something. The angle of elevation is how much you look up, the angle you look up at, from the bottom when you're looking at the top. Again, we'll be using our trigonometry rules and SOHCAHTOA because we're going to be calculating angles from right-angled triangles. In this first example, we're going to be looking at finding the angle of elevation of the lighthouse. This is the Cape Schanck Lighthouse, which is 21 metres tall, and I'm standing 35 metres away, this point over here, looking up towards the top of the lighthouse. So what angle would I be looking at? So we start off by labelling the triangle, and the triangle is actually here. And the right angle is in this corner here at the bottom of the lighthouse. So if I'm labelling it, this is the hypotenuse, the angle is here, and that's theta. So this will be the adjacent and that'll be the opposite. So for this one here, I've got opposite and adjacent, which is tan. So I'll be writing tan theta equals opposite over adjacent. Next, substitute in, and we know that opposite is 21 and adjacent is 35. And theta is the thing we don't know. So we do inverse tan of both sides because we want to get rid of the tan and find out what theta is. On the left-hand side, inverse tan cancels with tan, so we end up with theta equaling inverse tan of 21 over 35. And using a calculator, inverse tan of 21 divided by 35 is equal to 30.96, or that would be 31.0 degrees to one decimal place. So if I'm standing at this point here, 35 metres away from the bottom of the lighthouse, I need to look up at an angle of 31 degrees to see the top. And that's called the angle of elevation. In this example, I'm going to look at the angle of depression. When someone's standing at the top of a 700 metre building and looking down to the top of the 500 metre building, and there's a distance of 20 metres between the buildings. So it's a bit hard to see in this diagram, so I'm going to quickly sketch what we're looking at. So we've got a triangle that looks like this, where the angle of elevation, or depression, sorry, is there, and there's a right angle here. This is 20 metres, and this side's 200 metres. That's because we've got 500 metres to the top of the grey building, and this the red building is 700 metres tall, so the difference is 200 metres. So again, we use SOHCAHTOA, or we label our sides. So that's the hypotenuse, that's the adjacent, that's the opposite. So I've got opposite and adjacent, so I'll be using tan. So tan theta equals opposite over adjacent. Substituting in, tan theta equals 200 over 20, which is 10. We have to do inverse tan of both sides, and it cancels on the left, so we end up with theta equals inverse tan of 10, which is 84.3 degrees. So theta equals 84.3 degrees. And that's the angle of depression because we're looking down. So when you look down, it's depression. When you look up, it's elevation.